the interesting thing about angles is they're measured counterclockwise, right? So that's why you've got this little arrowhead pointing in this direction. This is a positive angle measure if it's moving counterclockwise. But that makes sense if you remember our numbering system for quadrants, which we've talked about in this class. This is quadrant 1, right? And that makes sense because that's where everything's positive, right? X and Y. So that's where lots of our work is done in quadrant 1. Then quadrant 2 is over here. Quadrant 3 is here. Quadrant 4 is here. So that again tells you a little more, reinforces why angles are measured in this direction. It's following a quadrant system. So basically the words you should know: terminal arm, initial arm, vertex. That when we measure, when we place an angle in standard position, the angle is starting on the positive x-axis and it's moving in a counterclockwise direction. Now the terminal arm can be in any one of the 4 quadrants, right? It could end in quadrant 1, the angle could end in quadrant 2, quadrant 3, quadrant 4. For example, if I just do another quick angle measure here, here's my initial arm, and the angle could be all the way across and end in quadrant 3. And there's another angle in standard position, right? What do you think this angle measure would be if you answer in degrees? Give me a possible measure for this angle. It's got to be greater than 180, right? 270 would be all the way 250. Okay, I'll go with 250. It's got to be between 180 and 270, right? So that's what a 250 degree angle looks like. Now, when you're asked to draw an angle in standard position, you have to show the initial arm, the terminal arm. You also have to show this little arc showing the movement of the angle and the direction. So if I ask you for positive, then the arrowhead's going to be pointing in this direction, right? We can also measure negatively. Here's my initial arm. Initial arm is always on the positive x-axis. So always on positive x-axis. And notice this though, if I'm asked to do a negative angle measure, I move clockwise, okay? And your angle, your little arc angle has to, or arc arrow has to show the negative direction, okay? Again, if this is my initial arm, my moving in a negative direction, I could end anywhere, right? If this is my terminal arm, then I show my little arc, my arc angle measured negatively. Someone give me a possible angle measure for this one. Negative 250. Awesome. Okay. So basically that's the only thing I really wanted to talk about today in terms of what standard position meant. Positives are measured counterclockwise, negatives clockwise. I also think this might be helpful for you too. And for all those people who struggle a little bit, let's start at the very beginning here. It says quadrantal angle measures. Quadrantal just means those angles that measure at the edges of the quadrants, right? Quadrantal angle measures in standard position in degree and radians. So this is where we start measuring in standard position, right? So this is 0 degrees or 0. And normally I don't put the word radians or rads, but I will this time because we're kind of learning. 0 radians. As we move positively, what degree measure is ends here? What's the degree measure at this? At 90 degrees. We'll come back and do radians in a minute. And then halfway around the circle is, of course, 180. I know all the way around is 360, but what is this guy? Just add 90 degrees onto 180, 270. Add another 90 on, and I'll get my 360. So that's moving in a positive rotation, right? I think we'll just stick to positives today. We won't talk about negatives. Now let's do radians. Any chance you get, you always want to answer in exact values when possible. So exact values mean once around, we've determined that it's just the way that radians were defined and created. Once around the circle is 2 pi radians, right? 2 pi, that represents a number, radians. So all the way around 2 pi. So halfway around would be 1 pi. And we know that that's how we started class today, right? That relationship, our pi radians equals 180 degrees, right? We started that. Okay, so halfway between 0 and pi would be, if this is 1 full pi, this is half a pi, right? And we call it pi over 2. Yeah, pi on 2 or pi over 2. Okay? Now, so let's see what we have here so far. We have 0 radians, half of a radian, 1 full radian. So what would this be? 3 over 2, right? 1.5 radians, right? Half a radian, a full radian, 1.5, 2. Now, how we write our 1.5s, mixed fractions aren't really used much pre-cal. It's always improper. We say 3 pi on 2 rads, or 3 over 2. Okay? And then we're back to 2 pi. Now, radians prove an interesting little wrinkle, though, because there are going to be some situations where, and we just saw it in our homework, where you're not asked to like, for example, if I just flip backwards for a moment, I want to show you the very first thing we did. Remember radians? When you were converting to degrees, I gave you pi radians, I gave you 3 pi, but I also gave you negative 2.35, 1.6. These are the radians that don't fall on nice quadrantal sites, right, or quarters of the sites or thirds of the sites. So just like degrees, there's weird degrees, right? Like I could give you 11.27 degrees. You're going to get weird radians that don't fall nicely on the circle. So in that respect, you also have to be able to think of the unit circle in a third way. It still involves radians, but you have to be able to think of radians in terms of their decimal equivalents, kind of, or approximations. Okay, this is 0 radians. Pi divided by 2. Well, what is pi again? You guys told me what pi was. It's 3.14 radians, right? Maybe I'll see if I have a different colored pen. I do. I think I have blue. I'll use blue. Now, I told you guys never ever use 3.14 if you can use pi. But sometimes you're going to be given weird radians, so you have to be able to acknowledge that pi is about 3.14, right? So I want you always to remember that 3.14 is an approximate value of pi. Okay. Let's do an approximate value of pi on 2. So just take your calculator and get your pi. Pi divided by 2 is about 1.57, right? So this is also approximately 1.57. And then 3 pi on 2, well, that's just 3 pi divided by 2. That's about 4.71 radians. And finally, I think many of you guys probably know what 2 pi is without picking a calculator up. Just double this guy, right? Or you can use your calculator, 2 pi. You've probably seen the 6.28 at some point, right? So this is about 6.28. Once again, 2 pi is the far better answer and measurement. Okay? But now, so the degrees I think you guys have nailed. I think you guys have been working in degrees forever. So you kind of have to learn 2 systems. They both involve radians. The pure radian measure, then the approximate radian measure. Most of our work will be done with the pure, the exact. Okay? So that basically gives us just another way to measure a circle. So when we do this, and I'm going to give you 2 things for homework tonight. I'm going to tell you finish this, and then finish that little assignment in your textbook, the arc length stuff. And all it says is sketch the following angles in standard position. And I don't want you to pull out a protractor, nothing like that. I just want you to use your instinct, right? And when you're marked on the exam for this, or you're marked in a test, I don't pull out a protractor or a ruler or anything. I'm just getting you, like, it has to be somewhat in the ballpark, right? So this is my initial arm. Doesn't matter what angle you're starting with, your initial arm is always going to be here, right? Okay, 23 degrees. Well, this is 90, right?
No.
Half of 90 is 45. Half of 45 is about 23, right? So kind of just do something like that, right? But you also have to show me the direction that you know it's going in positive. So that's about 23 degrees, right? What would negative 170 look like?
Just under the negative x-axis.
Yeah. Opposite direction right now. It's all negative 180 would be here, so just come a little short. Okay? Let's pick one more to do together. How about this one? 2.5 radians. Okay, so I gave you lots of radians in exact form, but now this one is 2.5. So where would 2.5 be? So I might want to look at my... Okay, what quadrant is 2.5 in? It would be quadrant 2, wouldn't it? Okay, here's 1.57, here's 3.14. It's kind of... Yeah, it's kind of in between, isn't it?
Yes.
Now, another thing you could do, I suppose, you could convert 2.5 radians to degrees and just think of in terms of degrees if you wanted to, but it's nice to get a sense. So it would be kind of halfway between 3.14 and 1.57, right? Maybe a little closer to 3.14, but I would do something like, right? Something like this. Then you have to show the positive direction. Okay, something like that. All right. This is just to help you develop a sense of angle measure, right? All right, I'm not going to do anything more for you. Just see how you do with this, right? It's just an example, so we'll talk about it when you get back. Just remember, negative angle measures are measured clockwise. So I'm going to get you to, now you've got lots of time, I'm going to get you to finish page 8, and I want you to finish the assignment in the textbook too. And do some pre-reading or rereading.